Good afternoon to everyone on East Coast, and good morning to everyone that's to the west of us. Thank you very much for your time and joining today our webinar. It's probably going to be the last webinar of this year, and with luck, next year we'll have more events where we'll get together in person. But for now, it's a very exciting topic for me. We're going to talk about software security testing. I'm Alexander Poisner. I am one of the founders of Parabellyx Cybersecurity. First of all, I'd like to thank my team at Parabellyx for making this webinar happen. I would like also to set a couple of housekeeping rules first. Now, I know that there are some people that are joining using the Teams for business client. We also know that there are some limitations if you're joining using either a web browser or using the personal Teams client. In this situation, the Q&A section where you can post question to me is not available. So that's why what we've done, we've opened chat as well. For those of you that cannot have access to Q&A tab because of the Teams limitation, just post your question through chat, and one of our moderators will copy and paste it to the Q&A session. And I'll stop a couple of times during the presentation to take questions, and obviously I will take a bit more questions to the end. If for one reason or another I didn't address your question, what I'm going to do is I'm going to release a follow-up video and post it on our YouTube channel, where I'm going to take all of the questions that we haven't addressed due to the time constraints during this webinar, and I'm going to answer them in that video. Also, if there is some kind of question that you don't like to ask in public, do reach out to us after the webinar, and we can have a private call where we can address the question. So, sorry, give me 1 second, please. Apparently, there is a small technical issue that we are going to resolve right now, and we can be on our way. Okay, sorry about that. So, software security testing is a very exciting topic for me because one of the things that Parabellyx does best is create that software security assurance practice for our clients. But today we're not going to talk about any sales stuff. We are going to deep dive as much as possible into the subject, and we're going to talk a bit more, not just about why the drivers, but we're also going to talk about things such as how they're going to build this practice, what are the tools available, what is the most efficient way of using those tools, what is the process that you want to build, because the practice is not about relying on the tools. It's all about making sure that you have a proper process in place, and obviously the skill sets. How are you going to create your DevSecOps team that will have sufficient skills to run with this program? But before we talk about all this, let's take just really a few minutes and really go through some of the drivers. And well, it looks like for the last 25 years or more, cybersecurity is officially one of the IT priorities. We have had a focus on everything, but really the application security. And that shows. One of the interesting things that we saw from Cisco Catalyst and their incident response team, for example, They have said in Q2 of this year that exploits of public-facing applications are pretty much overtaking phishing as initial access vector. And that's not just for breaking the applications and getting into the application data and customer data. It's also about things such as ransomware attacks. We've seen quite a few ransomware attacks being launched through gaining initial access through one of the public-facing applications in the organization. And that's only going to continue moving forward. Also, we still see the issue where a lot of organizations are prioritizing the feature delivery over security and don't really have expertise on building that application security practice. And a lot of times, I would say it's not really their fault. It's just the way the traditional cybersecurity has been, where they really haven't been enabling the application security assurance for software developers, and they were really slowing down the process. So today, hopefully, we're going to talk about how to build that software security assurance practice without slowing down the development process, without slowing down the release of the features. And really, application security, in my opinion, is going to be the next wave of cybersecurity. And we've seen, beginning from the 90s with the antivirus, there have been a lot of different technology waves, from the network security to cloud security, EDR, MDR, XDR, everything around trying to protect people from phishing attacks and awareness training. And the application security wave, it wasn't there. I mean, we've seen some tools such as web application firewalls, obviously API security tools, the operational tools around protecting APIs is something again worth mentioning there, but there hasn't been a lot of movement in terms of creating the holistic view from application security, not just from the operational perspective, but starting from design, doing the threat modeling, and then going into the proper testing, and then moving into the productions, into operations security. And one of things that we're seeing with our clients, but Gartner also shows this as part of the trends. If you look at that application security hype cycle that was released this summer, one of the interesting things that you're going to see is the DevSecOps itself. It's right there to the right at the plateau of productivity. Now, that's great, but what about the tools? And if you start looking for the tools around application security testing, well, most of those tools have not even gone through the through of disillusionment. So that just tells you, while people understand the value of DevSecOps and application security testing, they still have inflated expectations of the tools, and they expect that one tool is going to do everything. There are lots of debates on the internet, which tool from SAST, DAST, SCA, what is the most efficient tool? And there is no answer, because there is no most efficient tool that's going to do everything for you. It's all about the process. That's why DevSecOps is at plateau of productivity, and the tools are not even close. Now, one of the things that I'm going to, and this is the rationale why you want to start application security testing as early as possible in the process, is, well, if you just wait until penetration testing and then you get, let's say, some critical results or high risk defects in your application, the cost of going and remediating those, in our experience, is about 16 times higher than if we catch the same defects during the static application security testing using the SAST code scan. And you'll find a lot of other figures on the internet. Some people are saying it's 100 times higher, but from the statistics that we've collected with our clients, we see that it's somewhere hovering around 15, 16 times higher. But even worse thing is that if you have those critical findings, if you have those defects during the penetration testing and you need to go back and fix those, there is a cost to this, which is a delay in releasing of new features for your applications. And that average delay is around 2.4 months in our experience, which is very high in my opinion. So just keep that in mind, please, when you are building your practice. And that's another rationale why you shouldn't just wait until the end and rely on the penetration testing for your application security testing. And obviously, we've heard a lot about new regulations coming out. We've all heard by now about the Executive Order 14028. They've also incorporated this into the House Bill 4611, which is a defense budget. In essence, US and a lot of other countries right now are developing various regulations that are going to say, if you're supplying software to government, if you are a defense contractor, if you're supplying software to critical infrastructure, you have to do certain things from the software security assurance. Now, US probably is the most advanced right now in those regulations, but again, Canada, EU, UK, everybody else is working through their law passage mechanism, and they're coming out with regulations for that. So one of the things that it's interesting to observe, and this is a couple of organizations, NIST in US and OASIS in Europe, started developing standards around what should the typical software assurance cycle for cybersecurity look like. Now, I haven't seen the draft for OASIS yet. I just know that it's in work. It's not yet publicly available, but NIST has the IR 8397, which is, they call it guidelines for minimum software security assurance. And this slide, in essence, what I did is I took the requirements from that document. It's 37-page document. I took all of the requirements from that minimum standard, and I've just put them on one slide, and I've mapped them to each state of the software development. And as you see, it's quite extensive. I wouldn't say it has anything to do with the minimum, because most of the organizations that we are working with, they're still not there with doing everything that is required by the NIST IR 8397. So it just tells you that it's going to be an iterative process. I don't think that even from the government perspective, US government is going to enforce that full minimal cycle right away. But at least this is the vision that you need to adopt for yourself and prepare for. Not just if you work with US government or any critical infrastructure providers, defense contractors, but be assured that all of those, as well as financial institutions, will start pushing this down the supply chain, and this is where it's going to hit most of the software development companies. So one of the things that you want to do, at least the vision that you want to start with, is move away from we're going to do everything and then we're going to do penetration testing in the end, and that's going to be sufficient from our software security assurance perspective, to a more of And I hate to say it cyclical view, because it's really a spiral, since you want to keep improving on that rather than create everything and try the big bang approach, which in my opinion never works. But in the end, you want to have some continuous process that starts with the threat modeling and then moves through the entire cycle from the point where people develop stuff, commit their code, you analyze that code, as well as you do the dynamic application security testing once the code is deployed in some environment, hopefully the QA rather than the production environment, and end it up with the penetration testing and continuous security posture monitoring. The reason why you want to have all of those steps is you have to think about the security assurance, like any other assurance, is that you are going to work with different meshes to filter out and eliminate defects, from the most common and bigger one with the static application security testing, which is in essence code scanning for well-known defects, as well as the software composition analysis, which is just looking through your software supply chain and detecting any issues, vulnerabilities in the libraries or components that you're using from third parties, and going down to something that you do as part of the application testing, much like user acceptance testing, just testing various workflows for security defects once the application is running through DAST. And finally, using the finest mesh, which is the penetration testing, just to find everything else that remains. And that's the idea of the continuous application security testing. Now, usually before we jump into the next session, I would ask if there are any questions. I haven't seen any questions in Q&A yet, or in chat. So I see one question in the chat regarding the recording. One of the things that we're going to do is, yes, we're going to have a recording posted on our YouTube channel for this particular webinar. So if you want to share that with your friends, colleagues, by all means do that. We're going to send up a follow-up email with the link to that video. Probably it's going to take us couple of days just to make sure that we do the video processing and post it in a proper format, but it's going to be there before the beginning of next week, just in case that for whatever reason we need to drop off. So talking about tools, and obviously a lot of people wonder, well, there is the process, but what kind of tools are we using for software security testing? And few things that are kind of becoming the primary components of every software security testing program. So that's the threat modeling, the software composition analysis to create the SBOM, which we hear again a lot about software bill of materials and why it's important, as well as the static and dynamic application security testing. So let's just take a few minutes and talk about each one of those. Why should we use them? Why are they effective in specific scenarios, and how we should use them? One of the things that I'm not going to get into is the debate which tool is the most effective and efficient, because there isn't one tool that's going to do everything for you. They are very effective if you use them for specific scenarios and specific tests. And there is a rationale why you need to have all of that in place. So first of all, let's just take a moment to talk about the threat modeling. And threat modeling, it seems slightly out of place right in the beginning of the application design phase when you look at it from the context of security testing. But the reason why threat modeling is important to have, and important to have right at the beginning, is this is something that will let you understand the risks that your application is going to face. And based on those risks, you may need to change design to incorporate additional security features. But also, the reason why it's important for the testing itself is if you consider just take the standard list of threats, and you can grab it from Mitra, OWASP, other organizations as well. And then you're going to build your tests just using that standardized list. Well, that test list is going to be extremely expensive to execute. If you think about it, OWASP has the application security validation standard, which in essence gives you an exhaustive list of tests that you need to do. Now, if you look at the total number of tests, the number of technical tests that you need to execute as part of that validation standard is 270 something, just below 300. So that's quite an extensive list. And think about if between the static and dynamic application security testing, how much effort it is going to take to execute that. I'd say for the standard testing cycle, you probably want to prioritize certain tests over other tests. And that's where threat modeling comes in from the perspective of application security testing. But also the way you want to build that threat modeling is you don't really want to go and have a big bang approach where, hey, you know what, we already have a design, we started development, or God forbid, we've already gone through most of the development, and now we're doing that threat modeling, because that's going to be a huge amount of effort. That's why if you do it in this manner, you're going to have a delay because of the security analysis for the release. And the way you want to do it is, like I said before, in a spiral. What you're going to do is you're going to go with the design phase, have a certain high-level threat models created, and then as you go through your minimal viable product and set the feature for that product, you can do an elaboration a bit more in terms of specific threat based on the features and based on the initial use of the application. And as you continue developing and evolving the application, you're also going to create more elaborate threat modeling in this way. So there are a few tools out there. We're going to talk about the tools that are there a bit later, but there are both commercial and open source tools equally good for threat modeling. The next one, and that's something that a lot of you have heard about, is the software composition analysis. Software composition analysis usually results in a creation of what we call SBOM, the software bill of materials. And everybody talks right now about SBOM because pretty much every single regulation around the security assurance for software says that, hey, you need to manage your software supply chain risk, you need to create SBOM. So that's true. However, my warning to you is that SBOM and SCA is more of a compliance tool rather than a security tool. It's true that in many situations, it will allow you to detect vulnerable components. However, the problem with SBOM is when you're talking about third-party components, first of all, it only lets you see what those organization will show you. It doesn't really go and scan the entire code, open source code for stuff. What it's going to do is going to say, okay, there is something that's called a manifest, and there are different ways of producing this manifest for the packages, libraries, SDKs, so on and so forth. But it's going to look at that manifest, and whatever is in that manifest, it's going to show up on your SBOM. Now, the problem with this is if I don't have everything on that manifest, you're not going to see that. So that's why software composition analysis is not a replacement for code scanning tools, such as static application security testing tool, SAST, that we're going to talk about right now. And SAST is a great tool. The reason why it's great is, first of all, it allows you to scan the code pretty much right away. The developer has done some work, committed code into a repository, and you can launch an automated action of scanning that code as it gets committed. You can also have SAST scanner in your pipelines just to make sure that you do that continuous scanning. You can set up some gatekeeping parameters saying that, hey, you know what, if it has findings above certain level, don't continue with the build, but we'll talk about why it may be good or bad a bit later on, but it has a lot of capabilities. Now, one of the things that you want to remember about static application security testing is that SaaS tools are efficient for very specific things. And that is standard stuff that is the same for every single code, right? You're not doing input sanitization or input validation. You have some problems with injections. You have some problems with cross-site scripting. Your code, for one reason or another, may be susceptible to buffer overflows. Those are types of things that you are able to detect with static application security testing. Now, an interesting thing is that those are some, but not all of the security issues or security defects that you're going to have in your application. And that is why it is very important, rather than just relying on SAST, have something that is going to test security for the application that is already built and running, because SaaS tools are not designed to do security testing on your application business logic. Even simpler things, for example, you have an authentication workflow or some kind of session management workflow for users that involves SAML validation, and there are some custom components of SAML validation that your developers wrote themselves. SAST will not be able to detect any of those issues. It's really where you've already built application, it's running in one of your environments, and you are doing more of interactive testing on those applications. That's where you're going to find out all those issues. With validations, with business logic, with certain things of the exposed elements that should not be exposed as part of your interface, so on and so forth. Now, there are two ways to approach that dynamic testing, and that's why sometimes we hear DAST and sometimes we also hear IAST, interactive application security testing. They're kind of two different things. Now, IAST is a more modern invention. Again, I'm not going to argue which one is more effective because it's all about the process rather than the tool itself. But the difference is DAST simply does the testing through the application workflow, looks at various requests response from the client perspective, looks at various workflow transitions, at various interface elements, API endpoints, and such. IAST has a component running on the server. So theoretically, it can see more. Practically, there is an additional noise because that more may not really be exposed to user, and you may not have a proper way to assess risk in case of IAST findings. So the problem with DAST and IAST is there is really not a good way to automate it. I mean, you probably want to use some kind of third-party automation. A lot of companies started with Selenium and then moved to some different commercial components for the DAST testing automation. The other thing is it has lots of false positives. With SAST, you have right now, SAST, I would say, has about 40 to 60% of false positives in the findings. DAST can have up to 80% in false positives in the findings. And that's another thing that we're going to talk a bit later on is why we shouldn't trust those findings from the automated run. Why do we have to triage and validate those? And that's, again, the reason why you're not relying on the tools, you're relying on your process for the application security testing. And with that, let's just talk a bit about another component that you've seen before in continuous application security testing, but we haven't really discussed this part of the tool. And a lot of vendors will come in and say, hey, you know what, based on our tools, based on the findings, we have just-in-time training. Just if somebody did something wrong, if developer commits code and we see a buffer overflow or indirect object referencing in this code, we can right away run a training or enroll him into the training. And remember how I've said just a minute ago about the false positives in the findings? And this is the reason why just-in-time training in the automated fashion doesn't really work well. And it's like annoying awareness training that just keeps popping up regardless of whether you've done something wrong or not. So my take on just-in-time training based on our experience, just don't do it. What you want to do is you do want to collect that statistics and perhaps once a month, just run training for developers based on the top 10 things that you are finding as an issue with their code. Or with DAST, where it's not about the code, but more about the business logic design, so on and so forth. That's, again, where you may want to take that as an input for your training, but do not rely on the automated training just because of that sheer number of false positives that you are going to see as part of your software assurance program. So well, I'd like to stop for the questions, but I don't see any questions still. So let's just push ahead a bit more. So tools. All I'm going to say is there are lots of tools, commercial, open source. One of the things that we all know about cybersecurity is, well, we rush to buy tools. One of the things that I'm going to caution you, based on our experience in application security testing, is until you've built your application security testing process, don't go for tool procurement for one particular reason. First of all, there are a lot of tools out there that are open source that are good enough for you to start with application security testing. And it's going to take some time until you actually will start hitting limitations of those tools. And that's why my take always, use those tools, test your process, build out your process, Now, when you're going to go out and buy a commercial tool, once you've hit those limitations, this is going to help you tremendously because those tools will simplify your process. They're not going to complicate your process. Pretty much all of those that Gartner lists, they're going to make your process simpler. But at this point, you already know what to expect. At this point, things such as triaging the findings, verifying that you don't have any false positives, those things are not going to change. And you already have that particular process. Now, I've listed some of the tools. I mean, those are most popular open source projects like ThreadDragon from OWASP. OWASP have a lot of wonderful tools. Like, in my opinion, one of the non-for-profit organizations that does the best job right now for the application promoting application security, that's OWASP. So ThreadDragon is great. OWASP Zap for DAST, it's a fairly simple tool to use. Again, problems is automation, but automation problems are always there for anything that is doing interactive testing. If some of you try to use Selenium for things such as user acceptance testing, you will understand what I mean. So a SonarQube for SAST, again, great tool unless you're using some kind of weird development language that's not supported. Probably it's going to be good enough for you in the beginning. And 3D open source project by Aqua. They have container security scanners. They have cloud security posture management scanners right now. Again, great tools if you don't have any of those commercial tools. If you want to see more tools, go to OWASP, and OWASP webpage has a full list of both commercial and open source tools and some comparison around those. But again, just to reiterate, don't get hung on which tool to use. Just go out there, grab some of the open source tools, test your process with those, and then start improving on that. Now, let's talk about the process, because process is extremely important. And in pretty much 99% of the situations where we came to the client and helped them to do the application security testing, it's really the process that made it successful. Now, a few things to remember about the process. First of all, threat modeling requirements. If you have those, great way to prioritize your testing. And that's really something that a lot of companies are missing. A lot of companies are jumping into the testing without the threat modeling, without having the security requirements well defined, and that's something that kind of holds them down. The other thing is when we have code, there are multiple things that you need to do. First of all, SAST, easy to automate, so make sure you don't just use it when you're doing the build through the pipeline. Just do scans on commit. That's a great way for early identification of issues. But again, remember what I said about the false positives. And this is why you really need to organize your software security testing. And I hate to say it, much like security monitoring. You have a finding, you need to triage it. I'm sorry, but the gruesome reality is there are lots of false positives. And even if it's not a false positive, there is always a question of the true risk from that particular security defect that you have discovered in a context of the application. And that's something that you have to keep in mind. The prioritization that you get from the tool, it may not be a prioritization based on the threat modeling that you have, just because that particular component may not be exposed anywhere inside the application once it's published to exploit. Same thing with false positives. I mean, one of the things that, and it's almost a joke, but it's a good way of explaining how those a lot of those false positives are coming about. So, can anyone guess how many input synthesization frameworks are available out there? So, while you're guessing, I'd say that the ones that are kind of well known and well used, we're talking about close to 50. Now, top commercial SaaS tools will recognize up to 20 of those. So what about the other 30? Well, guess what? At this point, the scanner does not see that you're doing that input synthesization. If you're not doing this input synthesization, here we go. Probable SQL injections, you name it. So that's one of the good examples where a lot of false positives are coming from. And if you have that possible injection false positive, guess what? It always comes as high or maybe critical. So that's why triaging is extremely important, and it's easy to eliminate a lot of those. The other caveat that I'm going to mention, and that's again important in the context of triaging in the false positives, is if you have those scanners and you said, okay, it's a good idea to automate the scan results injection into the defect management, it's still a good idea from triaging perspective, but just make sure that you are using a separate defect management system for those raw results from scanners than the one that developers use for actually managing and prioritizing and remediating the real defects. So one of the things that we've seen a lot of companies are doing, they, for example, would have Jira for their defect management, and then they would have something even open source such as Defect Dojo. Well, Defect Dojo is moving from open source to commercial this year, so probably not the best example, but anyway, they use that for the security, raw security defects ingested from the scanners. Somebody from the triaging team will go look at those defects, investigate those. Once they're confirmed, once they're properly prioritized from the risk perspective, they move it to Jira. Again, there is a way to move those automatically from Defect Dojo to Jira. And this way, when the development team sees those security defects, those have been confirmed, analyzed, prioritized, and they know that they need to fix those. And much the same thing with the functional testing when you've already have application running in one of the testing environments and you're doing DAST or JUST scanning. Again, the same issue is with, first of all, making sure that you have the right scope. You don't go around executing all of the OWASP SVS level 1 tests just because you don't have your threat modeling and you don't have the testing plans. There is also another thing that is important with DAST, and that is regression testing. You have finding, you've confirmed that this is true, you've prioritized it. There is still possibility, once it's fixed, that after a few releases, it comes back. So you want to have a catalog of those tests that you want to run as regression testing every time, and you need to manage this as part of your DAST management as well through your process and retire those. And then again, as you move into environment, move to production, continuous testing is something that's going to be important, and that's around the environment testing area, right? We're running stuff right now in a cloud. Some stuff is in containers rather than cloud native stuff or VMs. So it's important to do the security testing on the environment and continue. It's important to do it continuously. Luckily, like I said, there are tools that can help us. You can integrate into pipelines. You can automate it. There are some commercial tools versus open source tools. And another important thing around that is, well, Now that we've done all of this, penetration testing is relevant, right? Well, wrong. The thing is, we are used to have penetration testing as a catch-all. And that's everything that is wrong with the application from security perspective, we're going to catch it through penetration testing. Now you're moving to another mentality where we've catched the most visible stuff through SAST, then through DAST, and then penetration testing is really the finest mesh to catch stuff that fell through the mesh of SAST, the mesh of DAST, and the mesh of the environment security testing. And that's how you should structure your penetration tests. And that's where penetration test still has value. It's keep in mind that unlike SAST, DAST, environment security testing, which needs to be continuous, penetration testing is always going to be a snapshot in time. But at this point, doing it on an annual basis or semi-annual basis, depending on your regulatory and security requirements, you are going to be fine because you know that most of the stuff has been caught through SAST and DAST. Now, one thing that I want to say is we've talked about the process. Now, how are you going to build that team? And really, DevSecOps team for application security testing has three components: the Dev, the Sec, and the Ops. Dev are the guys that know how to design and code. Ops are the guys that it's your reliability engineers that know the environment quite well and have done all of the automation and integration process. And Sec, it's the security guy that knows about threats, vulnerabilities, risks, various security tools, operational and otherwise. Now, here's an interesting thing. There are two extremes. Extreme number one, separate each one of those into different people. Extreme number two, trying to find one person that knows both Dev, Sec, and Ops. That's hard to do. The other one is not so efficient because you always need three people. It's like having somebody that knows to read, knows to write, and knows how to ask questions. So it's the first one is inefficient. The third one cannot really find resources like this. They probably exist, but I would estimate one true DevSecOps specialist in a single person for every 5,000 developers. So not realistic for most of the organizations. So what you want to do is you want to look for people to staff that particular function that have 2 out of 3. They're either Dev and Sec, or Sec and Ops, or DevOps people, and making sure that you actually have fulfilled the skill set by having either 2 or 3 people in that team that are going to kind of have some of the overlapping skill sets and some of the unique skill sets. And the real reason why the shift left fails in many cases is that rather than trying to build that desk set of teams, the management is saying, okay, we have a development team and they have some DevOps people. Let's just dump it on them. Well, guess what? Dumping more stuff on your development team is never a good idea. They already are doing enough. And moreover, they may not have that unique security skill. They can learn it, but have you asked them if they have time to learn it and time to ramp up that knowledge from the experience perspective? Probably not. So that's why people are saying shift left is basically take those security tasks, dump them on development team. That shift left is bound to fail. So try not to repeat this mistake. Now, one of the last things that we're going to talk about is, well, how do we put all this together? How do we build this practice? Well, first of all, we still want something that's going to guide us. So make sure that you select something like NIST IR or OASIS, something as your standard of framework to build in this. Like I already said, make sure that when you create the triaging function for security defects, you have a separate component, you have a separate system where you can do that triaging and tracking of the issues before you put it in a general software defects tracking system. Agree on roles responsibilities. As you create that team that is going to run with this, just make sure that they do have all the skill sets and they also have some overlapping skill sets so they can verify each other work, they can consult with each other rather than just being completely three separate skill sets that do not intersect. And then once we have it, it's really about making sure that you create the process. And you will never get it right from the first time. That's why I'm saying do the process, do it with open source tools, preferably, so you don't spend money. Once you're comfortable that this process is running, then first of all, start expanding it to the entire organization. And also, at this point, it's probably a good time to start looking at open source tool limitations and start selecting commercial tools. And the last one is really around CI/CD integration automation. Depending on how you do things in your organization, certain aspects of automation are going to work, certain aspects of automation are not going to work. So that's really trial and error. There is no single formula for every single organization that you can basically automate everything and this is going to work for you. And the last thing that I'm going to say is you also have the risk management and cybersecurity executives that do not have as much visibility into what's going on. So it's important to understand how you're going to design that risk view so they are involved, they are comfortable with the decisions that are being made as part of the DevSecOps process. And that's something, again, you can start with the reports, and there are also tools that can allow you to create that risk view for those professionals. And that's what I wanted to go through for within an hour today. I know that there is a lot of stuff that we've covered, so I encourage you, once we publish this webinar as a video, you can go back and review stuff that is being said. You can always reach out for us with additional questions. I see one question here on the chat from Albert saying it sounds like DAST tool is best when the organization is already in a mature state with the software development testing process. Otherwise, there is minimal value. No, I disagree with that. I mean, investment in DAST, given the fact that there are decent open source DAST tools, is not investment in tool. It's investment in the automation of the tool. Now, the reason why you want to have DAST is, like I said, stuff such as business logic, various security issues around the exposed components and interfaces. Those things you usually won't be able to catch with the static application security test in SAST. That's why investment in DAST is good. Just be prepared that initially, at least partially, you won't be able to automate it and you're going to run it manually. So make sure that you have somebody that is able to do it. I would also say, because DAST can function as a proxy, you can incorporate that into QA workflow. Somebody just goes through the user acceptance testing, just going through the entire workflow, have them run that tool in the proxy mode, just to do the general detection of the issues, and then do the triage and manual investigation of those. That also works. That means you don't need as much automation as usual. So that's one of the things that I'm going to recommend here. But don't don't discount DAST. It is still a tool that you need in the end. Any other questions? Well, if not, first of all, thank you very much, everyone, for coming. Saw some familiar faces, saw some people that we haven't talked before. Thank you, everyone, for joining. Like I said, if you have additional questions, don't hesitate to reach to us. Those who know us, they know that when somebody reaches out to us with professional questions, we do not go into that entire sales spiel, but we answer them right away. And that's because the way we treat all of our customers and potential customers as our partners, where we share knowledge with them. So thank you very much. If for those that we don't talk, have a great holiday season, and looking forward to seeing you in our events in the new year, both in person and online. Thank you, everyone.